Alright, we're going to do a little virtual tour of Mechatronics, and as with everything else before that we almost have in life, before we can get to the good stuff, we have to start with the stuff that's kind of theory based. Those three subjects are DC, AC, and solid state. Both of those are heavily into theory because first we got to understand what these things are before we can appreciate what they do. So you'll have three courses, very lightweight courses in DC, which is direct current, alternating current, which is AC, and then solid state. And the reason you need those courses is they deal with the devices that you interact with as a mechatronics technician. And to kind of jump back for just a second, mechatronics is really related to industrial automation. So mechatronics, Japanese word, it's a marriage between mechanical and electrical. So mecha for mechanical and tronics for electrical / electronics. This is just a sample of one of the pieces that's used to teach you DC. You can see here we've got a NIDA trainer. All of this is online. It teaches you what the individual components are, how to measure voltage, how to measure current, how to measure resistance and that kind of thing. And it does it very systematically, very intentionally, and gets you used to doing this through repetitive action. So you're going to see the same thing over and over and over, but that's how it eventually sticks with you. So you'll learn all about the basics of electricity, both direct current and alternating current. You'll move into solid state. Then you're going to get your hands on some really neat trainers. We're going to be bringing those up here very soon. This yellow device you see with the leads that the gentleman's holding there, that's a multimeter. That's going to be your biggest piece of equipment you use as a mechatronics technician. This will be the stethoscope that a doctor uses. This is a frontline instrument that you would use every day if you're not familiar with that. And this particular meter is capable of measuring voltage, current, resistance, and many other things. So this is just a quick look, and again, if Steve changes screens over here on the computer by hitting the right arrow, the next, you'll see that it's going to ask you questions, and again, it's going to guide you through. It's going to give you text, it's going to give you study notes, and it's going to take you through, and eventually it's going to have to quiz you, and this is an experiment within NIDA doing one of those quizzes. So this is how you're essentially going to learn your first three lessons in mechatronics. Okay, this is one of the courses you'll go through. There's actually two motor control courses. This is kind of the one I call that has training wheels, and that's because everything we wire using these little banana plugs right here. And that makes it a lot easier and a lot faster, but it lets you get used to the individual components. Eventually you're going to be wiring those components by hand, just as you would in the field. But I've got here just a little manual motor starter. I've got three-phase power coming in here. We are live. And I've got a manual motor starter here, and it's wired up through my transformers over to my motor. You'll hear that motor kick on. So essentially this is just a on-off switch to turn the motor on. So when I press the green button, you can possibly hear that motor coming on, and when I press the red button, it stops. So very simple circuit, and again, just as with everything that you're going to study, we're going to take you through the very basic information and lead you into the more complex. And this Amatrol equipment does a great job of that. And I'm going to take the camera off as soon as we finish this shot, and we're going to come around and just kind of give you a high-level view of each of these components. So the picture will be a little jittery, but I just want you to see some of the things that you're going to be encountering. Alright, this is the Amatrol motor control system, and I apologize, this camera will not zoom back any further than what it is. And again, I'm trying to show you my equipment, not my camera skills, but as I mentioned before, we've got a disconnect right here that disconnects our three-phase power. We are hot. If you look in, you can see L1, L2, L3. If that means nothing to you, it will be by the time you finish this course. Up here we've got different types of switches. We got a couple of start switches. We got a selector switch in the bottom right hand corner, and we have an e-stop, and an e-stop is always a very important safety part of any motor control circuits. Up here we got control relays. Again, these are relays that we can turn things on and off with a very low current device. We've got indicator lamps. We've got the manual motor station. This is the one I pressed a while ago. You'll be able to see the motor come on when I press the green button and cut off when I press the red, just as it did. So this is just a very simple motor control device. This is a transformer. Well, you'll get into exactly what those do. They either step up or step down voltage, and you'll see the application when you come through. Got a limit switch. This is a way we know devices are either closing or opening a switch, just depending on how we have it set. Limit switches are typically found on conveyor systems, like when a box moves into place, it'll close that limit switch, and then we can make different decisions based on the state of that. All kind of different switches, including pressure switches, level switches, basically a float switch. As the air pressure changes here, whoops, I'm out of the frame. As the air pressure changes here, then the switch can either open or close. Same is true with the float. Down here we got some capacitive, inductive proxies and photoelectrics. Those are sensors that can be made without physically having to touch the device, so just when something gets near them. Down here we've got a reversing contactor. This would allow us, if hooked up properly, to make the motor go forward or reverse, but never at the same time. In fact, these have mechanical interlocks where both of those could not be energized at the same time, because if you try to turn a motor forward and backwards at the same time, good things will not happen. Next to that is an overload relay station. This is a device that protects the motor should there be some kind of high current situation. And then there's just many other things that go into motor controls. But again, we introduce you to everything from switches to contactors to relays to lamps. We do that individually, and we do it in such a way that it makes sense to you as to what they're being utilized for in the field. So that gives you at least some sense, I think, of what a motor control circuit does. And then we're going to move over to the field device, the one that looks like what you'd be hooking up. It's got much of the same stuff that you see here. It's just you'll actually be terminating wires on it. Okay, this is the motor control learning system, electrical wiring learning system, for it goes by another name. But this is the one that's very similar to the one we just showed you, where you wire up with the banana clips. But with this case, you're actually going to be doing the terminations, and this one is a bit more complex, but it's pretty much identical to what you would encounter in the real world. The trainer we looked at with the banana jacks, I failed to show you. It actually takes you through some books that has a good bit of knowledge. Of course, we always have trainers around, instructors around that can assist you if you have an issue. But what I really love about this trainer is the fact that it uses a multimedia system to guide you through. I'm going to take you through just one slide, and then we're going to come over to the trainer like we did a while ago. So what I love, like I say, is it's got pictures, it's got audio. Forgive me for getting in the frame, but I've lost my mouse, and I know it's here somewhere. Here we go.
When feeding wires by hand, it is common practice to tape the ends of the wires together. This makes it easier to push them through the conduit. If the wires snag while feeding them through the conduit, wiggle the wires or pull the wires back to free them and then feed them forward again. Continue to hand feed the wires until they appear in the panel to which the wires are being fed.
So again, it gives you instructions, it gives you industry tips, it gives you ideas. So let's take a look now at the trainer itself, and we're going to take a high-level look, kind of like what we did, and then I'll bring the camera over and get a more close-up view. But what you see here is essentially everything you saw on the trainer with banana jacks, but arranged more like you would see it in industry. So you've got this big control bay here, and inside of it, it's all kind of devices from transformers to contactors to relays to everything we talked about behind us. A couple of new components we'll talk about when we bring the camera over. Over here is our lamps, our e-stops, our switches, so very similar. So you can see here the difference is, rather than plugging in banana jacks to make these devices work, you're actually terminating wires. And the beauty of this system is it goes through wire colors, wire sizing, the whole 9 yards to help you understand what wires to use, what gauge, that means size, that you would need of that wire, and what colors the NEC, which is the National Electric Code, wants to see for AC and DC wiring. So again, we've got some motors down here you can't see. They're kind of below the angle of the camera, but again, we'll get to that. But in addition, we've also got some pneumatic controls over here that can interact. So this gets into some actuators that we can make happen electrically. And again, we're talking about mechatronics. We're talking about a blend of mechanical and electrical, and this is that at its finest. So now we're going to pause a minute. I'm going to bring the camera over, and we're going to look at some of this a little more closely. All right, we're taking a look inside that control bay. And if you look in the upper left-hand corner, I'm going to kind of zoom in on those. You'll see reversing contactors. Again, that's very similar to the one you saw behind us. Both those can't be actuated at the same time. Next to it is a couple of devices that you hadn't seen yet. One is a drive system, and that has to do with controlling motors, everything from frequency to you name it. So different parameters we can, excuse me, I took that off camera, but you see power flex there. Different ways of controlling motor speed through frequency and other variables. Next to it's pretty much some of the same things you saw behind us. Instead of having fuses here, we do have breakers right here. And next to that's our transformer. We do have some fusing inside this interlock here. This, the trainer behind us uses AC control. This uses DC control. And again, we don't expect you to know that. Just making you aware that we do have two types of control. And when I speak of control, I'm talking about typically the operator side of things. I prefer DC, but AC is also used industry-wide. Next to it, we see Siemens PLC, and again, a PLC is an automation device. And in fact, there's two separate classes on that. So, but you can't avoid blending these things. Down here are some relays. They look very much like a contactor. They just have a different application, similar, but usually different. So they work pretty much the same, but again, when we hear the word contactor, those are typically driving a motor. A relay can be driving some other device besides a motor, turning it on or off. And again, we don't expect you to know these things, but we do take you through systematically so that you do. Also over here is the control box, the switches and buttons. And you'll see inside of it, you got terminal blocks, which is this long thing right there. And then the back of the switches. And again, we're going to explain all that to you. Some more disconnects down here going to our three-phase motors. And then we talked about the pneumatics cylinder that we have. That's the control box for it that I didn't open. And where we can, we're trying to put these shadow boards so that we can have tools near the point of use. You'll see those here and there throughout the shop. But again, this is the second motor control system that we have. The other thing I like to do is expose you to different types of meters. So you'll see we started out with a fluke meter. Behind us, I didn't break it out. On the first motor control, we had a Klein, and here we have an amprobe. And that's because you never know what you're going to be using in the field. They all work similarly, but they're all a little different in their way of measuring these things. So being able to reason out how to use a meter is always a good thing. Okay, we're going to talk about PLCs, and you'll have in Mechatronics a couple of PLC classes, and PLCs are an integral part of industrial automation. They're kind of the backbone of the programming world. They make things happen. So you can see right here we've got a station, and I'm going to show you again these individual parts a little closer after we're done. But what PLCs are is they can replace a lot of components that you saw in the motor controls. They can't replace every component, but they can replace a lot of them. And the beautiful thing is, instead of wiring all the componentry together, we wire them to either input boards or output cards, and then we program within the PLC's processor what needs to happen. So what that does is it lets us make changes on the fly a lot quicker, because we're not having to undo wires and rewire in new components. We just have to wire them to the I/O cards, the input-output cards, and we can make new things happen that we couldn't do as easily on the motor control side. So, and in fact, in the second cabinet we showed you, the one where you actually did the terminations, it does have a PLC in it as well. So again, a PLC can do a lot of things that some of the other components can do there. And what you see here, and I'm going to kind of walk over first to this trainer itself, is we've got a slick processor up here, and it's got some input cards, it's got some output cards. And again, we don't expect you to know this, but the four basic parts of a processor are its power supply, its CPU, and its inputs and outputs. And those are your 4 basic things you have to have in order to have that. Now some of them come in a little package controller like you see here, and it's all one unit, and you've got both power supply, processor, and inputs and outputs pre-built into this little package, which makes it nice because it's a small profile device that you can use. So anyway, you're going to get to all those. But we've written a little program, and we're going to move over to the HMI, and this just gives you a minimal idea. We've got a traffic light over here that you can see, and we've got this HMI device, and you can't see anything but the red light. I understand that there's a lot to take in here, but we can actually control that output using this HMI, human machine interface device. And we had to do that by writing a program for both the PLC and writing a program for the HMI. But it's just one way that us humans can interact with a PLC and make things happen. That all happens here. I'm going to turn on the yellow light. You might be able to catch a glimpse of it over the table there. And of course, same thing happens with the greens. Not only can we turn them on, but we can see them come on both on the light itself and on the display. If you notice, the red light is now off. It's not on the red light. Neither is off on my HMI. But when I do turn it on with the button, it comes on in both places. So I'm going to pause the video here for just a second. We're going to take you and let you look at some of these individual components. All right, this is a video, and programming of PLCs is done in ladder logic. The reason we call it ladder logic is each one of these is called a rung, and when you add multiple rungs, it looks kind of like a little digital ladder. So that's where we get the terms ladder logic. And it's really pretty simple when you look at a basic program. We're saying if this input is on, turn on that output. Right now this input is on. This input's tied to the HMI. So I'm going to go over to the HMI. I'm going to turn that input off. We see the output went off, and this program is actually not connected live to the processor, but if it were, we would see that go off inside the processor. This is just a copy of what's in there. So we've got a way of communicating with our processor here. We've got our I/O chassis right here, and besides having this programming means we've got other units that fit this trainer besides this motor. So we've got various pieces of equipment that you can program and troubleshoot here, and in addition we've got a simulator. So probably as a mechatronics technician, you're not going to have to do much programming yourself, but being able to troubleshoot a program, the easiest way to troubleshoot a program is to know how to program. So if I can teach you how to program, then you can certainly go back and look at somebody else's program and understand what you're looking at and get a better feel for troubleshooting it through that method. So this is just one of the pieces of equipment that we use over here next to us, and you can kind of see the traffic light again in the background. There's a little conveyor belt, and it's got a couple of sensors right there that you can see in the center of the frame. It's got 3 different electric actuators there. And you've got these multiple size discs, so you can actually program this little conveyor belt to recognize what type of disc it is and sort them based on the diameter or the height or a combination thereof. And you can see it's using a little package controller as well. So again, I'm going to show you some of the simulator stuff after this, and what I love about the simulator is this is something you can take at home. You don't have to be in front of a piece of hardware, but the programming works exactly the same as if you were in front of a piece of hardware. So that's what I like about the simulators for PLC, is it gives you the opportunity to do some of your work away from the lab. 1, 2. Okay, I mentioned simulators and PLCs, and again, the beautiful thing about this simulator is you can write a program on this and take it out to the real world and it'll do exactly the same thing. Now our inputs may have a different number, our outputs may have a different number, but the program that works here is going to work in the real world. What we got here is a little door simulator. I'm going to close the door, and of course the idea is to be able to open and close the door on this little wall we've got here. So we've got a door big enough, obviously, for a bus to go through, if you can see it on the screen. We've got inputs and outputs, and we've got buttons. We have an open button, a closed button, a stop button. We have an ajar lamp, an open lamp, and a shut lamp. Have a limit switch that lets us know when the door is all the way up. We have a limit switch that lets us know when it's all the way down. And we've got a motor up and a motor down. So again, these would all be wired to an input or an output card. Inputs if they're buttons, outputs if they're motors or lights. Basically anything you turn on and off is an output. Anything you monitor is an input, a switch or a sensor or something like that. So this is just one of the simulations, but when I press open, this thing will open. And if I tried to press close, if we didn't allow for it, we could actually turn on both motors at the same time, and it would burn up the motors. But this particular person that wrote this program wrote the program so that we couldn't press both open and close and have that happen. So everything that we need to do to get that door open is right here in this program, and you see on the right hand side that ladder diagram. So the beautiful, like I say, the beautiful thing about this is, whereas I have one piece of equipment over there, I've got multiple seats of this particular PLC software. And within it is the door simulator, a silo simulator where we have to press start, bring a box over here, fill the box up. When it's done, it moves on, the next box comes in. We also have a traffic light simulator, a traffic light 2 sides. We also have a batch simulator. This is where you have 2 different intake pumps. You pump fluid into this tank. When it gets full, and you know that by the high sensor, you have to mix it, potentially have to heat it, and then have to drain it. And additionally, we have a BCD IO simulator, which we don't cover in this course. We do have a couple of air compressors, and we've got an elevator. And between the elevator and this one, it's probably the most complex, the bottle line simulator. Those two, the elevator, the bottle line, and the BCD, you don't see in your course, but they're available to you if you purchase a CD, which is only like 50 bucks. And the good thing about this, you can do this from home and practice and keep your skills up. So it's well worth the money. But this is just one way that you can practice PLCs at home and get a feel for how this works without having to be in the lab, but really see something happen based on the program. This is the process control system. Using this trainer, you'll be introduced to the different devices used to control a process. So obviously, when we've got a process out there, we've got different ways we can control that. So this has everything from sensors to flow transmitters to a PI&D controller, process meters, inputs, outputs, and what you're doing is you're controlling the flow of the water out of this tank into this reservoir up here. So it takes you through and it introduces you to all the various componentry used in process control, or at least a large portion of those that are utilized. So a lot of nice equipment right here, a lot of good opportunity to learn more about ways to control a particular process. Okay, I want to take you now through this Mechatronics trainer, and this Mechatronics trainer is really awesome because it puts the students in front of a real live process. This makes a little valve body. Let's see if we've got any pre-made down here. Yes, we do. And so forgive the camera angle while I reach for this, but you can see this valve body right here. And what it does is it starts with just the basic block. It puts on the knob. Before it puts on the knob, trying to unscrew this with one hand, and let's get some pieces. So obviously it's got to put on this knob that you see here, and in addition, it starts with this basic valve body that you see here. It inserts a spool and it inserts a screw into that valve body, and we saw that on this other one a moment ago, and I can show you both the screw and the valve body here. Let's get this door open. So there's 2 different types of spools. I kept saying screw, I meant spool. 2 different types of spool, and one is for the acrylic, one's for the aluminum. And if you look back here, you can see the screw head protruding out of there. So I'm going to run this thing, and there's just so much here. I mean, obviously, you can see right here we have Allen Bradley PLCs, and we have Siemens PLCs. So we've got a mixture of those, and we've got 7 independent stations. This first station here is designed simply to spit out the valve bodies, pick them up, inspect them for proper positioning, and then carry them over to the next station, which will traverse them over to our indexing table. If there is a need to reject one, this cylinder that you see here will spit it into the reject pile. Otherwise, it goes to our index table. And this index table aluminum blocks are there is no offset. So when you look at the hole here that the screw and the spool will have to go in, it is the same distance from the top to the bottom. However, on the acrylic, they're not. So what this station can do is this gripper right here can actually flip them if there is a need to flip those valve bodies. Then it's going to go to the conveyor system where acrylics will go one way, aluminums will go another. And then when it gets to the end, our FANUC, which by the way is the #1 robot used worldwide, we also offer a certification on that. Our FANUC robot will pick it up, bring it over here to the station where the spool and the screw inserts, and that's going to be hard to see on camera. It's hard to see in the real world. Then it's going to pick it up again, and then it's going to come over, and we're actually going to torque the knob down, or torque lightly tack it on, I should say. It's going to move over, and then it's going to go to the torquing station, which is, move these doors a bit, right here. And after it's torqued, it'll move on, and it'll be properly stored in the slides you see here. So a lot going on, a lot to learn, more that I can really cover in a quick video, but let's watch the action happen, hopefully, and you'll see. So we're ejecting part, picking it up, bringing it over. This is an aluminum, so it's going to bring it over to the index table. It's going to index around, be inspected, and if it were acrylic here, it could be flipped, but obviously I said aluminums were the same. The aluminum block moves toward the back. It's coming over. The robot's going to go grab it, and we'll see if we can get a better angle. The robot's picked it up, brought it over. I'm going to try to get where you can see that happen. And here comes the spool and the screw. It says the robot fully clear as air. Now we're moving over, getting the knob tacked on. The robot's going to come grab it, bring it over to the torquing station. And we're going to torque the screw in. Then we're going to bring it over and actually store it. Hopefully it's at the station's offline. Let me reset it and see if I can catch up. So the only thing we missed was the storage. It's like the storage station. I was trying to be a little persnickety this morning, so we can run it manual. Not even cooperating in manual. That's okay. So what would happen is this gripper would pick it up and store it. So it's all pretty much all the processes here. And so again, this is just a way of getting students in front of a working process that would be similar to what they would see in the manufacturing world, letting them see, you know, everything from the PLCs to the power supplies, to the contactors, to the motors, to the stepper motors on this index table, to the various type of sensoring used across the industry, pneumatic, MAC valves, electrical controlled valves. So just a plethora of opportunities to get in front of things that would be used to control a manufacturing process in the real world. I had that camera zoomed in pretty heftily, but I'll run down the line one more time just to let you see. And there we are. Hope the tour has helped you.